For this class, we'll be going a little bit further from where we stopped last week, and we'll just be we'll be looking at uh, come in, uh, we'll be looking at much more things with class and object. But we'll just be improving on the code we wrote last week so that we can get more used to it. So, but before we open that one today, I just want to show us the practicality of what we are talking about. So I just opened one of the files of the software I showed us then. That's the hotel management um, system that I showed us then. This is just one of the files. This as you can see, this is public class. This is the name of the class, login VM. So there's what we call view model in MVVM framework. So, but as it is, the name of this class is login VM, and you can see this full column and something in front of it. We'll be learning that today. This is what we call inheritance. So, it's inheriting some stuff. This view model is also a class itself. It's also a class. So now, if we look at the login view model class now, it has some properties, some members, just like we mentioned last week. I believe we can identify this. This is a property. This is a property get set. Now this is a method now, but this method now is a constructor. It's a constructor because it carries the name of the class. So when you have in a class a method that carries the name of the class, it is called a constructor. And such method will be called automatically as you create an object from the class. So this is a constructor now. That means anytime anybody tries to create an object of login VM, it automatically runs this method. And what's inside this method? Okay, now I may not be able to explain all this for now, but they are just some instructions. Some instructions. This is a relay command. You understand? These are just uh, they are related to WPF. I don't know if to explain that, but I just want to explain so that we can see the members. So you can see now, this is um, this is a field also. This is a field also. Then this is a property also, having the get set. Then now this is a field. Then this is a property. Now you can see what I'm saying concerning property. You can see now this one is a little bit more sophisticated than just the one we wrote last week. Like in this case now, I have a username, small username, which is um, this is the one that will be seen, that will be accessible outside the class. Anybody that try to create an object will only be seeing this. Person won't see this because I actually want to protect the username. I don't want anybody to just have access to the username easy like that. And I don't want anybody to just put any value inside this username because it's a very, very precious variable for me, because username is something very fragile, because when you have access to it, you already have access to the software. So I make it private. And this is what when you create an object, this is what you can relate to. So when you are trying to set the value for this object now, you should carry out this check. So this check is trying, okay, if username equals value, that means the new value you are bringing, if it's equals to the normal value that is already in the username, just return, don't do anything. Then if not, then equate the new value that is coming, equate it inside the username. Then this is a method, a raise property change property method. There's a function it does in WPF, which is beyond the scope of this class. So now this is the getter. So when you're trying to get this method, it returns my value I've actually protected. And this is also another one, and just like that. So if we see something like this now, I don't expect us to be scared. So if you see something like this, okay, this is a field, this is a method. Though you may not understand, or now this is a method now. This is a method up to this point. So all these are being done inside this method. So, but when you see this now, okay, this is a method. This is the name of the method. The name of the method is login exe. Then is returning a task. The task is also a data type, but it's an action. It's an action. It's an action. So now, is it just like the way you return int and double and all that? Then this is asynchronous. That means I want this program to run. I want it to run. I want it to be run at the same time when some other background program are being carried out. So now that's a method. This is a this is a method also. This is a field. This is a property, and just like that. So you can see that all that I have inside my class, they are nothing strange. They are just members. They are either fields or properties or their methods. So if you go like that, if I open another file, you see the same thing. They are just like that. So there are places where I made use of these classes. Let me just okay. Let me introduce a little bit of WPF to us. Take for example, like that login VM now. Um, Let me show you where it is being made use of. Okay, let me go to my views and okay. Then is that login XML? Okay, I'll give sometimes take some time to load out. So this is just WPF. Don't need to bother yourself about this. You may not be doing WPF after the whole bootcamp. You may be going into mobile, you may be going into web, and you may be want to go into desktop, whichever one you want to go into. But this one is just strictly for desktop. So now this is as you can see, this looks like HTML, but it's not HTML. It is called XAML, XAML. So it's like HTML, but it's not HTML. So this is what handles the front end of the desktop application. It's what handles it, and this is where that method is being created. So when I open the sub file in this now you can see this now. This inherits from that login VM, and this particular file is what it does automatically. As you can see, S type argument is running. When this file is being opened, it automatically creates an object from the class I've created. So that's why I can see it assigned login VM. So that's just that. I just actually want to let us know that we are already close to where we are going to. So OOP is just, so maybe you want to start programming anything now. You already understand OOP. You just need to understand the technology. And you now need to learn how the technology works. Maybe you want to work on WPF now. You now need to know, okay, how does XAML work? How does this work? If it is .NET Core, okay, how do I write my view controller? How do I write my uh, how do I write my views and all that? How do I integrate it with the front end? So let's go into what we are doing for today. So which is just a step ahead of what we did last week. So I'll be open last week project. So before we continue, I want to ask, does anyone ask any question from what we did last week? I will briefly go over everything again before we touch what we have today, but I want to welcome questions. So from all we did, we talked about a lot of things last week, and I mean, we want to apologize that sorry for rushing us because I know it's not that easy. So is there any question from what we did last week? Any question, Mr. Ayodele? Any question?
No, I don't have a question.
Okay.
Yeah, same here. I don't have a question for now.
Okay. That's great. So, last week I said we'll just be building on this. So last week we created class and we called it human, and we added some fields to that class. And we have name, we have I number, we have notes. Then we created this is a property now. Created a property. Then we created method. Created a method called it. Created a method called say name. So when we finished with class, so we actually came and we made use of we created some objects, as you can see here. We created some objects from that class. And we emphasize that class is just a blueprint. So you can create as many objects from a class. So it's just like you have a framework for where you are going. So you can actually create as many instances out of that framework. And we learned that when we are saying we are creating instance or we are creating objects, we mean the same thing. And this is the way to do it. So this is the way to do it. So the name of the class is human, and we created an object called person one. So and we said it is through the name we've given the object now that we reach out to those members, those attributes in those classes. So human has an attribute called name, but we created an object called person one from it, and through that object we could reach out to those properties. So we can actually from here begin to set the values of those properties, begin to manipulate it. But when we create another object, just as we can see from here, they don't interfere with one another. So this one has its own set of values, its own set of variables. This one is a fresh object itself. It's a fresh object itself. So we can create as many objects from a class. And also last week, I also said, just like you saw from what I showed us, you can have thousands of classes, depending on what you want to do. So as you can see now, our our project file is already increasing. We already have like 4 files here, and it's like we are not even doing anything. So imagine if you're actually working on a project, you may have calls to create as many classes depending on the problem you are trying to solve. And you don't have to necessarily have to come and click here and add new files and add new class. No, you can, just as you have class here, this class program, it ends here. You can, after that class, create a new class underneath it. So you can have as many classes in a file. But people create class to just avoid long lines of code, because a class can be very, very long in itself. So people create different files. So when you create different files, okay, maybe they want to maybe files that are related to one another, they will try to put them in a folder so that they can easily know and identify those files. So before you know it, your files are getting much more. So you begin to work with like up to 200 files. So you have to be putting them inside folders so that you can easily identify them. And that's how programmers build code files. And it looks like at the end of maybe 3 months, like plenty files. So it's from one concept to the other concept. And last week we spoke about something, and I will explain it much more. We talked about access modifier. Let me comment this out. We talked about access modifier. What if I want to create if let me go to Eman. Now, what if I want to create an attribute and I don't want people that I only want that attribute to be accessible only inside my class? That if you even create an object of my class, you can't make use of that attribute. So that brings us to what we call access modifiers. So you only want a particular set of people, a particular range of people to have access to some files. So now when we talk about access modifiers, we look seeing many of these public, private, what is it meant for another? So now in a class, when you create a field, a method, or a property, anything, and you call it public, that means every object that is created from that class has access to such members. Now, if you can see my screen now, I have a field called name, that's small letter name. So I have it tagged private. Now, private now let me go to where we made use of it now. Now we created uh, a new we created a new object called person one. Now let me try to set the value for person one dot small letter name. Now as you can see, it's not appearing, it's only showing me the big name. The small letter name is not appearing, if you can see from here, but we have small letter name. Now this is because we've told that particular attribute inside our class that I only want this particular field, this particular method to be available only inside my class. Only inside my class. So when you name a field, a property, or a method private, that means it is only accessible inside your class. I can make use of it. You can see that this and I made use of name, small letter name. I can make use of it inside my class. So now, but when you declare anything to be public now, that means it is accessible by when you create an object of it, it's very, very accessible. Very, very accessible. Now, there's another there's another access modifier called protected. So let me create that protected, and how can I protect? Let me protect Iman. Mm, okay, let me make it speech rate. So double, and I call this speech rate. So now that's another new one I've done. So let me go to my objects if I have access to speech rate. So now person one dot speech. I don't have access to speech rate also. Does it mean private and protected they are the same thing? No. I've explained private and I will explain protected in let me start by explaining protected. Now we understand what private is, that private is only private attributes are only available to the class. Now protected, now when anything you give the access modifier protected, is only available to the class and also classes that will be inheriting from that class. So today we'll be looking at inheritance, so we understand what inheritance is. So protected is a step a little bit ahead of private. You can make use of it inside the class, and you can also make use of it inside class that inherits the class. So we'll be looking at that very soon. So now we also have okay, that's access modifiers. We look at access modifiers. So we looked at static. I don't think we didn't look at static methods last week. Now, when you create a static class, just like we have here, I created a static example. When you create a static class, what it means is you don't have to create an object to make use of the attribute inside the class. I will come again. Now, if you can see now, this is a class called static examples. Is the name of the class now. It's just like every other class. This is a field inside the class. This is a method inside this class. So we have two attributes inside this class now. But there's something unique about this class now. Okay, let me go back to Iman that we created now. This Iman now, we didn't put public. Now, when you don't put public and you don't put anything now, the access modifier is not only for the attribute inside your class. Your class can also have access modifier. So that means where do you want the class to be seen? Where do you want it to be seen? So if I make it public, it can be seen throughout anywhere I can open another project, I will still be seeing Eman as a class. But if I make it, it's what we call internal. If I make it internal now, that means I can only make use of this class inside this my project. Then when I make it private, that means I can only make use of it inside this namespace. Inside this namespace. Okay, so now normally I said if you want to make use of class, you have to create if you want to make use of some attributes inside the class, you have to create an object. But when you name any class static, that means what you mean is you don't need to create an object to make use of the attribute inside the class. Take for example, static example. If I come to our work, I don't need to say maybe static examples and say std x1 and say equals new stds1 and blah blah blah. No, I can just say static examples and I say dot. Okay, I'm coming. Okay, we are running out of time, so when this section ends, I will encourage us to quickly come back to the class. So coming, trying to make use of that. Okay, let me try and touch it inside my. Okay, so now as you can see, static example. I never needed to to say let me create a new object before I could make use of this current vag is a member. This is it, as you can see from here. This is it here. So when I was trying to make use of it inside my human constructor, please don't get confused. So but now I wanted to make use of current var. So normally I was supposed to do maybe static examples and say maybe std equals new static examples, and I do blah 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 and this and that. It's already ruling it because static examples, they are static classes, so I don't need to create an object before I can make use of the properties inside. So that was why I can just immediately through the name of the class, just okay, static example current var. I can actually equate this. Let me equate this to this. So now static example current var, it's already carrying an initial value here of 1, so I can make it 4. So now when I call it here, it will just automatically go and collect the properties over there and help me store it inside iNumber. So that is just static classes. So static classes, and in a static class, when you have a static class, you must definitely have static attributes. So the static thing is just that you are not creating an object before you have access to the properties. You don't need to create an object. So that's static. So and we also talked about constructor. We talked about constructor last week, and I think I've touched it. Constructor is just a special method that gets called automatically. So maybe you have some code you want to run immediately as soon as your object is created. You put them inside constructors. And I said last week that constructors also have parameters. You can decide to put parameters inside. So like this one now, this is having a single parameter. This does not have a parameter. Now you can have as many constructors in a class, but they need to differ by the parameters you put inside. So that was why in our main implementation, I could create an instance of new man. So now when I created this particular object now, what we run will be this. This will get run. Now, when I created the object for this now, for this now, for this, now I've put a parameter inside of it. So you can see Sheyi, which is a string. So that Sheyi will come and represent what we have here, to be occupying the position of name entered. So this will be run instead of this. So I can decide to create another method and name it public human, but it should have maybe different numbers of parameters. So that's the concept behind constructors. It helps you save time. Maybe there are some code you want to run automatically. Now, before I move on, is there any question, please? Any question, Mr. Ayodele, Mr. Timileyin?
No, I don't have a question.
Okay. Okay, so let's go straight into the spices we have for today. So now, when you hear about OOP, POP, object-oriented programming, it has some unique features that I'll be explaining. We will touch 3 for today, then the remaining ones we'll touch them next class. So there's what we call inheritance, there's what we call encapsulation, there's what we call polymorphism. Now, forget all the big grammar. Some of these things, we've done them in these examples. We've done them. And let me quickly explain inheritance. The concept behind inheritance is, take for instance, we created a class called student last week. We created a class called student. So this is a class, we created this together last week. Now, what if I have a class that has some properties that is so generic, and I want to create another class, but I don't want to recreate some methods inside. I don't want to recreate some method again. Let me use our example. For instance, now we have a class called Iman. We have a class called student. Now, student is an Iman, and a student eats. A student has nose. A student has eyes. So instead of me creating some methods, there are some methods that we have inside Iman, like eat, say name. So instead of me creating those methods again inside student, can I just inherit the properties in Iman? So that's the concept of inheritance. So you can create a class that inherits, just like people inherit possessions, Anjogun and all that. Sorry for Yoruba. So you can inherit those properties from that class. So now that's the concept behind inheritance. And when we are talking about that, then we're talking about two things now. We're having a base class and we're having a derived class now. Now, the base class will be, in our case now, will be the Iman, and the student will be the derived class. That means student is a derived class that is deriving some properties from Iman. So when you have a derived class in such sense, now when you create an instance of the derived class, you automatically have access to the properties of the base class. So instead of rewriting many codes and all that, so they came up with the concept of inheritance. So we can see the power of OOP. So instead of me rewriting some methods inside Iman and rewriting them inside class student, why don't I just inherit those properties? So let's do that. So now, this is how you inherit. So when you create, I want student to inherit Iman now. So if in front of the class, class, just put a colon. then you put the name of the class you want to inherit, which is the base class. So I'll just put Iman, and that settles it. So as you can see, I've inherited Iman. So we can see Iman now. So now, if let's now go to our implementation. When I was creating, I created new students here now. Now, as you can see, some properties in Iman: it, say name, I number, speech rate, and all that. If I come to students here, I will have access to it. So I can then, I've created updates last week from std1, and I say dot now. You can see I have access to it, I have access to I number, I have access to say name, I have access to the details, both those that are inside Iman and those that are inside student. So you can see the power of OOP. So if I want to set those properties now, I can say, okay, for student 1, maybe this student has 4 eyes. So I can decide to set it here now, and that settles it. So this section will be ending now. So let's us rejoin so that we can continue and finish up with inheritance. So the session will end in few minutes. Oh, Mrs. Goodness, you're welcome. So I will encourage if you try and get the video after the class, so that you can understand some of the things we've done. Although many of them revisions though.
Okay, sir. Good afternoon, sir.
Good afternoon, ma'am. So this session will end now. So let's try and rejoin.